Hello students. So in this chapter alternating currents we are remained with the last topic which is called as transformers. Okay, so transformer is the last thing we are discussing in this chapter, alternating currents. Okay, so this is transformer is fully a theory part. Okay, because of the lack of blackboard I'm using the same method to discuss about this topic also. So for that I initially apology for that. Okay, so as I'm telling, transformer is nothing but it is a device. Transformer is a device. Which kind of device? It is a static device. Transformer is a static device which is used in the electrical purposes for increasing or decreasing the alternating voltage. Means if you want to make any changes or if you want to make any variation in the alternating voltage. Okay, so if you want to decrease the alternating voltage or if you want to increase the alternating voltage, okay, so we are using the transformer. Okay, so how can we define this transformer? Means transformer is a device. Transformer is a device used to convert low alternating voltage low alternating voltage at higher current low alternating voltage at higher current into high alternating voltage at lower current. How? Means transformer is a device which is used to convert low alternating voltage at high current into high alternating voltage at low current. Means as I told you initially, transformer is a device which is used to increase or decrease the alternating voltage. So how can we define it? We can define the transformer as it is a device which is used to convert low alternating voltage into high alternating voltage. But here we are involving the current also, as low alternating voltage at high current low alternating voltage at high current into high alternating voltage at low current. That means what? We are, if the alternating voltage is low, it is at high current. If the alternating voltage is high, it is at low current. Understood? Or vice versa. Transformer is a static device used to convert low alternating voltage at high current into high alternating voltage at low current. Or transformer is a device which is used to convert high alternating voltage at low current into low alternating voltage at high current. Understood? So this is how we can define transformer. Understood? I think you have understood the definition of the transformer. Okay, initially sorry for using this book method to discuss the theory part, but I don't have blackboard for discussing this. That's why I'm using the same, but I totally take care of understanding this topic clearly to you. Okay, don't worry about that. My only intention is you should understood the things properly. So for that I'll go slowly and I will go clearly. Don't worry about that. Okay, so as I told you, transformer is a static device used to convert low alternating voltage at high current into high alternating voltage at low current, or high alternating voltage at low current into low alternating voltage at high current. Understood? So this is about transformer. Okay, so if we are having these two phenomena, if you are having these two phenomena here, so you should have two types of transformers, because phenomena are two: low alternating voltage at high current and high alternating voltage at low current. So that's why according to these two phenomena we have two types of transformers. We have two types of transformers, that is step up transformer, step up transformer, and second is step down transformer. Understood? We have two types of transformers: step up transformer, step down transformer. So what is the difference between these two? So the transformer which converts low alternating voltage at high current into high alternating voltage at low current. Understood? The transformer which converts low alternating voltage at high current into high alternating voltage at low current is called as step up. Means whatever the alternating voltage is low, it will make it high. Means low to high, it goes low to high. That's why the name step up. Understood? Low alternating voltage at high current is converted into high alternating voltage at low current. This is step up. So what happens in the step down? Step down, high alternating voltage at low current is converted into low alternating voltage at high current. Understood? Means what? It goes from high to low. High to low. The step up transformer goes from low to high. Low to high. That's why the name step up. Means from bottom to top. It goes from bottom to top. That's why step up. So here high alternating voltage is converted into low alternating voltage. Means high to low it comes. Means top to bottom it comes. That's why step down. Understood? Means according to these two phenomena we have two transformers. Step up means low alternating voltage at high current is converted into high alternating voltage at low current. Understood? And in the step down, high alternating voltage at low current is converted into low alternating voltage at high current. That's why it's called step down. Okay, I suggest you go on writing the things in your book. Understood? Go on writing the things, because this is completely theory part. Go on writing. So this is what step up transformer means: low to high, low to high, step up. So here it is high to low, step down. Understood? So with relation to these two definitions, we are having the diagrams also. Diagrams, how we are having the step up transformer and how we are having the step down transformer. Understood? Symbol for step up transformer is step up transformer is, it goes something like this. Initially we are having an iron wall here. So here we are having one coil. Call this as a P, primary coil. And here we are having a one more coil. Call this as secondary coil. So this is what symbol for step up transformer. Understood? Next, for step down, again a metallic wall, and like this. This is primary and this is secondary. This is for step down transformer. This is symbol for step up transformer. This is symbol for step down transformer. Understood? In other words, what I can say is step up transformer gives us increased alternating voltage. Means what? It goes from low to high. Initially it was low, the output is high. Initially it is low, but the output is high. Understood? In the step up transformer. But in the step down, initially it is high. Initially primary cell is high, but the output is low. Understood? So step up means it will give us the higher input from higher output from small input. Step up. But in the step down, from the large input we are getting the small output. Means high to low. Hence it is called as a step down transformer. Understood? Go on writing the things. What is step up transformer and what is step down transformer. Okay. So this is about what types of the step up and step down transformer. So By looking at these two diagrams, you might got a basic idea about how the transformer will be. Understood? How the transformer will be, the basic idea you might get. Okay. Okay, that means what? We are having the two coils here. See, P and S are two coils. P and S are two coils. We are having the two different coils in the transformer. This is the basic idea you might got from the step up and step down. Okay, so this is step up and step down transformer. So we are having the two coils here, primary coil and secondary coil, which are wounded on the same iron core. We are having a iron core or iron wall in between the two coils. This is the basic construction. Okay, so let's go and study about the transformers one by one. So the principle on which transformer works, the principle on which transformer works is, this is very important question to be asked in your exam or viva questions in the practical anything. The transformer works on the principle of mutual induction. The transformer works on the principle of mutual induction. Mutual induction means we are having two coils, na? Secondary coil and primary coil. We are having the two coils. So in between those two coils, whatever the mutual induction process is happening, because of that the transformer works. You might heard the name mutual understanding, mutual friends, like that. So between the two coils of the transformer, whatever the induction takes place, mutual induction, depending on that the transformer works. Understood? So the principle on which transformer works is mutual induction. An EMF is induced in the coil when a changing current flows through the one more coil. Means you are having a iron core or iron wall here. Okay, we are having the two coils. We are having two coils. What are those? Primary coil and secondary coil. We are having the two coils like this wounded on the same iron core. We are having the two coils. So in between these two coils, they are not connected to each other, they are kept nearby each other. Understood? So an EMF is induced in the coil. If a EMF is induced in this coil, so the current flows through this coil also. Understood? Means if the current is flowing in this coil, that current will affect this coil also. Understood? This is the process of mutual induction. Means they are not connected to each other, but they are placed side by side. They are placed nearby each other. Hence, whatever the EMF is produced here, that will produce here also. Understood? So this is the principle on which transformer works. Understood? So construction also we can think, means we can understand the construction also very easily. So what is the construction? As we know already, we are having the two separate coils. They are wound on the same iron core. One of the coil is primary coil and other is secondary coil. But how they are connected? How they are connected means, see here, just I will show you. Just consider like this. Means if any if any conductor you consider, okay, so you consider here we are having the primary coil. What is this? Primary coil. And here we are having the secondary coil. Okay, this is what? Secondary coil. Okay, so this primary coil is connected to one source. Call this as EP. Primary coil, it is a source of an alternating voltage. Primary coil is connected. Okay, in the same way, the secondary coil is also connected to one output. Secondary coil is connected to output, like you consider, call this as ES, call this as ES. Understood? So this will give us the output. You can also call this as the load. Okay, so primary coil is connected to a alternating voltage source EP, and the secondary coil is connected to a output, a load, which is called as ES. Okay, so now whatever the primary coil is there and it is connected along with the source of alternating voltage, this circuit, whatever you are getting, whatever this much circuit you are getting na, to this you can call it as a primary circuit. To this you can call it as a primary circuit, and this is secondary coil, whatever you are having to this with the output, with the load, you can call it as a secondary circuit. We can call it as what? Secondary circuit. Okay, so you are having primary circuit and secondary circuit. Okay, so this is how the arrangements are done. This is how the arrangements are done in an transformer. Okay, so now you can also consider this as, means, see here what I am showing here, both are connected along with the single support. Means you can also see here, whatever the both the whole one, the primary, primary coil and secondary coil I am considering like this. So here it is connected to the what? This is what? The alternating voltage source, and this is what? The output or the load. Okay, so this diagram shows this is an arrangement in which primary cell and secondary cells are on the single limb. Primary cell and secondary cell are coiled, are winded. They are winded on a single limb such that one winding is on the top of another. Means primary and secondary are mixed here. So they are winded along with each other on the single limb. Understood? So this is the arrangement. This is how the construction. This is what? The construction of the transformer. Okay. So now how the transformer works. This is how now how the transformer works. The important part is theory. The principle, construction and theory are very important. For 5 marks you may get the question on transformer. Explain the construction and principle of the, explain the working and construction of the transformer. So at that time you have to write its principle, its construction, its theory, all the things you have to write. Understood? So now let's start how the transformer works. How the transformer works. Okay, so as I told you, we are having the two coils, primary coil and secondary coil, and they are connected to a alternating voltage source and a output. Okay, so EP is connected to the primary coil. Means what? An alternating current flows it here. Here this EP is the alternating voltage source and it is connected to what? Primary coil. Hence, in this primary coil what happens? An alternating current flows. In this primary coil, alternating current flows. So, due to the current, due to the flow of alternating current in the primary coil. So from this alternating current starts flowing in this primary coil. Because of this alternating current in this primary coil, an alternating magnetic field is produced. Means current, because of the changing current in this coil, because of this source, current starts flowing. So as the current starts flowing, the current starts changing. So because of the changing in the current, alternating magnetic field is produced. Understood? And hence the changing magnetic flux is linked with the coil. Understood? This you have studied already. So in this, current is there. Because of change in the current, magnetic flux is produced, and because of that, the changing magnetic flux is linked with the coil. Understood? So because of this changing magnetic flux, an EMF is induced. You know already from the laws of EMI, because of the changing magnetic flux, EMF is produced in this secondary coil. Understood? Only this much is the theory. What? From this source, current starts flowing in this primary cell. So because of change in that current, magnetic field is produced. So the changing magnetic flux is linked with both the coils. Understood? Changing means, if a source is kept here and around that if current is flowing, means in this source if current is flowing, around that magnetic field is produced. You know it already. So here already we are having the changing magnetic flux. Hence the changing magnetic flux is produced in these two coils, and in the secondary coil an EMF is produced. Understood? So this is what exactly the theory is happening. Understood? So now you consider that NP is the number of turns in this primary coil, and NS is the number of turns in the secondary coil respectively. Okay, and as you know, the iron core is capable of coupling the whole of the magnetic flux pi. Understood? So in the both primary coil and secondary coil. Okay, so now in this situation, what you have to do, you have to apply the laws of EMI. You have to apply the laws of electromagnetic induction. Faraday's law of electromagnetic induction. You already know what is that. That is number of turns into changing magnetic flux. Okay, so now this Faraday's law you have to apply in this condition. You have to apply in this condition. What is the EMF produced we have? That is, you consider it as a EP, because that is the voltage. EP is equal to minus NP into d pi by dt, because in the primary cell we are having the applied voltage as EP and the number of coils is NP. So means number of turns in the coils is NP. Okay, so that is EP is equal to minus NP into d pi by dt. Pi is nothing but the is a changing magnetic flux. Okay, so now the EMF induced in the primary coil. Now what is the EMF induced in the secondary coil? That can be written as ES is equal to minus NS into d pi by dt. Call this as equation number 1. Call this as equation number 2. Okay, so now divide equation 2 by equation 1. Divide it by 2. So what happens? ES divided by EP. So what you will get? ES is nothing but minus NS d pi by dt whole divided by minus NP d pi by dt. This is cancels, minus minus get cancels, NS divided by NP. Understood? So what you are remaining with? ES by EP is equal to ns by np. So this ratio ns by np is there na, you can call it as the transformation ratio. Whatever the ratio is there, es by ns by np is there na, means number of turns in the secondary coil to the number of turns in the primary coil. This ratio you can also call it as a transformer ratio also. Understood? So moving on to next. So here finally you get es by ep is equal to ns by np, call it as a constant k. Okay, so we are having some things here. If k is less than 1, means k is less than 1 for step down transformer. Step down means what? Higher alternating voltage to lower alternating voltage. So k is less than 1 for step down transformer. Means if k is less than 1, so k can be less than 1 only if numerator is less than denominator. That means what? ns is less than np, or es is less than ep. That means what? The output alternating voltage is less than input alternating voltage. Understood? Means output is less than input. Means see here in this diagram only, step down transformer, output is less than input. Es is less than ep. Yes, Es is less than ep. Understood? Now understanding? Okay, so what happens to the step up now? K is greater than 1. So here if you want the k to be greater than 1, np should be less and ns should be greater. So here ns is greater than np. That means what? es is greater than ep, means output is greater than input. Output is greater than input. Output is greater than input. Step up transform. Understood? This is very easy if you understand. Okay, again you go 10 seconds backward and listen to it once again. What means this ratio, transformer ratio, k is less than 1 for step down transformer. So mathematically you see here, if k is less than 1 means what? Obviously ns is less than np, means es is less than ep, means es means what? Output is less than input. So for it is step down transformer. So for the step up transformer, what happens? K is greater than 1. That obviously means ns is greater than np and es is greater than ep. That means output is greater and input is lesser. Understood? So this is what the things you can understand. Okay, so for an ideal transformer, we totally have output power is equal to input power. This is for what? Ideal. Ideal means what? Model, means adarsha. So for an ideal transformer, output power is always equal to input power. Okay, so if ip and is are the input current and output currents, then what is the output power? Output power is what? Es into is, because es is the output voltage and input means ip into ep. So for an ideal transformer, what happens? Es into is equal to ep into ip. Understood? Or also you can write es divided by ep is equal to ip divided by is. Or also in general, what you can write? ep and ip are inversely es and is are inversely proportional. That's why E is inversely proportional to I, you can write. Means what? The the voltage increases with decrease in the current. In the definition only we told the high alternating voltage at low current. High alternating voltage at low current is converted into low alternating voltage at high current. Means what? Whenever the current is maximum, the voltage is less. Whenever the voltage is maximum, current is minimum. Understood? That's what we can think. Okay, so in the transformer, it shows that the power transformer voltage increases with decrease in the current, or current increases with decrease in the voltage. Understood? So this is what about the transformer. Okay, and for a transformer you can write the efficiency factor eta. Eta is what? Output power divided by input power. Output power divided by input power means what? Eta is equal to ES into IS divided by EP into IP. This is what the efficiency of the transformer. Efficiency of transformer is what? Eta is equal to ES into IS divided by EP into IP. Okay, so for an ideal transformer, efficiency eta is 100%. But really, in fact, the efficiency is only about 90 to 99%. No any transformer is 100% efficient. Okay, so there occurs some energy losses also. Means, as you know, no any device is perfect, but no any device is accurately giving its capacity. There occurs some losses, some leakages, there will be there. Okay, so here transformer also, no any transformer is 100% efficient. The efficiency lies from 90 to 99%. There will be some energy losses in the transformer also. Okay, so in the transformer also we are having some losses, like we have the copper losses, we have the iron losses, we have the eddy current losses, we have the hysteresis losses, like that 4 to 5 losses, energy losses in the transformer we are having. Okay, so in the next class I will discuss some energy losses in the transformer, and we will discuss about some problems. Okay, so what is the exercise today I am giving to you is try to list. We already have that tradition. So what is homework for today is HW. Okay, list the formulas. List the formulas in alternating current chapter. List the formulas in alternating current chapter. Okay, so if you come to the next class with a list of the formulas, it's better to you only to solve the problems. Okay, so in the next class I'll try maximum to deal with the board. Okay, so that is the way, that is the correct way of teaching, and I too will feel better in that only, and I know you too will feel better in that only. So okay, I'll try. Okay, so in the next class we'll discuss about some energy losses in the transformer, and we'll solve the problems, and with that we will conclude with this alternating current chapter. Okay, but while coming to the next class, please don't forget to list the formulas. Okay, after that, after finishing the numericals or problems, I will also give you the notes also of the AC in whole. In a single PDF I will give you the notes also. Okay, so one more thing, while coming to the next class, you just revise all the things which we are discussing in the alternating current chapter, and if you having any kind of doubts, please contact me and please be clear with your doubts. So next class will be the last one to discuss about the alternating current chapter. Okay, so two things, list the formulas and come with the queries and discuss them in the next class and get clear with them. Okay, thank you, take care.